So, as promised, today we will be discussing about mathematical functions, because we should know what is a mathematical function in order to proceed for solving the limits on the function, right? So, if we talk about a function, so it is nothing but a relation between set of inputs and set of possible outputs, such that each input is uniquely associated with the output, right? So for example, if I take, so I can write down as f is defined over real numbers, okay, and the set of output numbers is also a real numbers, and we can define this equation by fx is equal to 2x plus 3. So this is a function, right? This is a relationship between the unique association between the input and the output. So input is x, the output is fx, okay. So here we the functions are very way to express relationships and dependencies between quantities, okay. So if we really want to take out, so we can always take out, like if we take any real number input as x, like if x is equal to 1, then f of 1 will be equal to 2. We'll put the value of x as 1, so 2 into 1 plus 3 is equal to 5. Now if we take fx is equal to minus 2, which is again a real number, so f of minus 2, because here we had x, so we wanted to find the value of function at x is equal to minus 2, so we can write it like this, and we will substitute x by minus 2 over here. So what we will get here is minus 4 plus 3, which is again minus 1, which is again a real number. So this mapping ensures that each input is associated with a unique output, okay. This is a simple linear function which represents very fundamental block in mathematics, right? But there are different types of functions we will be discussing here in this video only. But first of all, let's discuss what is domain, right? So let's just dive into that. So domain of a function is set of all possible input values for which the function is defined. So this represents the permissible values that can be used as input to the functions, right? So for example, if I take now in previous example we took 2x plus 3 was our function, and we had defined our function to be input values belonging to real numbers and output values belonging to real numbers. So this is our domain. Now if we take another function like p of t is equal to root of t, so this is square root of t, right? So here p will be defined by a real number which are greater than equal to 0. So this is a very crucial thing. Let me explain you why. So output can be any real number. Why this is very crucial thing, that our input must be a non-negative integer value. Why a non-negative real number? Because the square root of a negative number is undefined in the real number system. Okay, so the domain has to be specified that only a non-negative values of t are allowed over here. Let's take another example where q of y is equal to 1 of by y, where q is defined over domain as r, but excluding 0. Now why 0 is excluded over here? Now only one number had to be excluded, that's we wrote it in curly brackets, okay. Why? Because why we have excluded 0 over here? Because if division by 0 is undefined, right? So I need to exclude this. So this function is defined for all numbers. This q function is defined for all real numbers except for 0. Okay. So this was domain part, right? Now let's go to the range, right? So range function. Right. So range function mathematics refers to a set of all possible output values that the function can produce for its given input within the defined domain. Right. We can't go beyond the domain. That's an important thing. So let's take an example like fx is equal to x plus 1. Here we have there is much of so our function can be defined over real number as the domain and result as the range. So it can operate on any real number and it will produce any other real number. In this case the range if is all real number, right? So for any real it's the function produces a unique real output. Okay. So how we can define this as a range of f whatever the function is f is set of all possible values that f can take. So okay, let's take another function which is g of x. So this is equal to sine of x. Now how we are going to find the mean and everything, where g is defining all domain values of real numbers, right? But the output to be range is only defined. This is a simple which is minus 1 to 1. Now the range is limited to y because the sine function oscillates between these values. So if we find make any sine function, always get like this. This will keep on oscillating these values. And this will be some minus 1 and this will be 1. Right. Okay, so it's really wide. You can also say that range is a subset of the codomain, showcasing how the function behaves within its defined limits. Now understanding the range is essential for grasping the overall behavior. We want to know about the behavior of the function. It is very important that we understand how range is working, what are the aspects of range. And we should also identify the possible outcomes for different inputs as well, right? So it gives us a variety of very valuable sites, right? Within its specified domain. Also we could also know about the limits of the function's outputs within the specified domain. Next, what we can discuss over here is types of function, right? So let's do one thing, that we will be discussing about types of function in our next video, and we will be discussing here a very unique thing, another another building block of calculus, which is continuity. So this is a very important thing. It's continuity. What is continuity? So let's this is a very fundamental concept in calculus only, which explores the smooth and connected behavior of the functions. A function is deemed continuous at a point if the limit of functions as it approaches that point exists unequal the value of the function at that point. It might be a little confusing. So what we can do is take a function fx equal to sin x. Over the interval 0 to pi, right? This trigonometric function is continuous on the entire real number line. Specifically within the given interval, this function does not exhibit any kind of abrupt jumps or breaks, smoothly transition between values. As x approaches any point within 0 to pi, the limit of sin x exists and coincides with the value of sin x at that point. Right, that's why we can say that the function is continuous on the interval 0 to pi. Okay, so this is very important when we will be discussing about differentiation or integration, right? So we really need this continuity. Okay, so uh, let's dive into. Okay, we'll discuss a few types of function over here. We'll be just naming them and we'll be discussing more of them in the next video. So types of functions. So we have constant functions. Okay, so constant function, if I want to take an example, it is more of like fx is equal to c, where c is a constant value. Next is linear function, like we had earlier discussed, like fx is equal to 2x plus 3, right? Don't worry, we'll be diving into these functions in our next video if you're not able to understand, because we will be doing applying limits to all those functions, and we'll be seeing how to find limits for them. Quadratic functions, here fx will be of the form of ax square plus bx plus c, and the condition that a is not equal to 0, this is really required, because if a is 0, then the degree of this polynomial won't be equal to 2, so this can't be then quadratic function. So for this to be a quadratic function, a cannot be equal to 0. If I talk about generalized of this is mx plus b, where m is slope and b is the y-intercept. So this was linear function, so this was quadratic function. Next we have is exponential function. So exponential functions are of the form of f of x is equal to a into b raised to power x, where a and b are constant and x is in the exponent. Okay, let me just clear this frame. And next is logarithmic function. These are of the form of f of x is equal to log bx. Now this b is the base of logarithm, right, and this is our variable again. Next we have is trigonometric function. Right, so these trigonometry, as we had studied in previous classes, so it can be f of x is equal to sine of x, or cos of x, or tan of x, cot of x, cosecant, secant. Okay, we can use any of these. Sorry. And then we have piecewise function. Now this is very interesting function, right? Here what is defined as f of x has a certain expression, a different expression for different interval, like so f of x is equal to x if x is greater than equal to 0, minus x if x is less than 0. So here you can see when x is greater than equal to 0, we have to use this expression for fx, and if x is less than 0, then we need to use this expression for the function to find the value of the function. Next is rational function. So rational functions are the ratio of polynomials, so we can define them as f of x is equal to p of x by q of x, where p of x and qx of x are both polynomials. Right, so if I take an example, I can write down here as f of x is equal to x squared minus x divided by 2x plus 1. Okay, so where p of x is x square minus x minus 6 and q of x is 2x plus 1. Okay, so this were all types of functions we have. Okay, in the next video we will start discussing about how to find limits for different types of functions one by one, and basically how to find out the limit. Also we will be discussing some concepts of limits, like we discussed about continuity. We'll see how continuity is important while finding the limits of the function as well. Okay, so take care for now, and we will meet you in the next video. See you. Bye.